Finally, I finally did it! A fully portable soldering iron with internal battery. No more power adapters, cables or heavy soldering station cases. And this iron weighs only 81 grams, and it could reach up to 450 degrees, which is more than enough for me and is all thanks to this. This is the tip that I use for my design, and it's all I've been searching for a long time. Now that I have it, let me show you how I've designed such a soldering iron, the PCB that we need for it, and all the components, and show you how to make one. It gets interesting, so stay till the end, and your interaction with this video gets these kind of projects going, and me sharing them for free on my website as always. So thanks for your likes, your comments or watch time. That being said, let's get started. What's up my friends, welcome back. These are not all but a few of my previous versions of a portable iron, and later we will see the new PCB. It always got smaller and smaller, but it still needed an external supply of some sort of above 12 volts, because I was using the T12 tips, which on a lower voltage won't even reach 100 degrees. And that was always the problem, the supply. As you can see, at 4.2 volts it only generates 2 watts of power. But I wanted my iron to have an internal battery, so it could be fully portable. So I wanted to use a lithium-ion battery like this one of 4.2 volts. So to get the same power from the tip at only 4.2 volts instead of 12 volts or more, I needed a tip with a low resistance. And for that I've been testing more than 20 different types of soldering tips. I even tried to make one myself, with a combination of nichrome wire and a thermocouple, but it failed. And in a previous video I did make this other soldering iron with an internal battery, but you see, the tip that I used for that project had no internal thermocouple, so we can't know the temperature. So instead of power, that one was using a timer. You count up to 10 and stop the heating process, and that was it. But I wanted my new iron to have a temperature control as well, and luckily I found this tip. So let's check what we need. First of all, my new design of the PCB. Actually PCBs, because we need 3 of them. The controller PCB, the PCB for the OLED screen, and a smaller PCB for the USB input for the battery charger. If you also want to make this awesome project and challenge yourself, you can download my Gerbers for the PCB from below. As always, I've used the services of PCBWay to create these awesome boards. Once you have my files, go to PCBWay.com and click the Code Now button. And here select your settings. I leave all by default and I set the color to red. On the next page upload the Gerbers and make the payment, and just in a few days I receive my PCBs. And this design turned out awesome, because it's small and with a weird shape, and let me tell you why. To understand why, we need the next component, which is the iron tip. And these are from AliExpress, and they are branded as Sunshine, but they look suspiciously as a copy of the JBL brand. Anyway, I like that these tips can deliver a good power at only 4.2 volts, and that's why I can finally make my project small and compact. And because I want the iron to be compact, the tip should go inside of it, and that's why the PCB has this weird shape. The tip will go here and get in contact with the PCB pads. So the first thing I made was to make the clips. For that I've used some copper sheets. I cut them to size and make some sort of cylinder out of the copper, and that will fit the 3 stages of the tip. I make sure that it fits and I solder them to the PCB. So now the iron tip is held in place and also has connections to the circuit. Now that I have that, I can solder the microcontroller, the resonator, the DTR capacitor and the pull-up resistor. And now I must test if it works. So as always, I connect an FTDI programmer to the UART port, which are these pads for the RX, the TX and DTR. Upload any code and if it works, we can continue. I then solder all the components, the TP4056 for charging the battery, the op-amp amplifier for measuring the thermocouple from the tip, the MOSFETs for controlling the power, and some other smaller components. For example, this is a very small SMD vibration sensor, and I want to use this to detect the sleep mode. I also have this buzzer for sound notifications. And then these other MOSFETs here are for turning on the circuit, because if you check the circuit, you can see that I have no switch. I want to use this latch system to turn the PCB on without any switch, just one of the push buttons. And these buttons and the screen are on the second PCB. And the negative of the battery and the USB charger are on this third PCB. This small board has a battery clip and a USB Type-C connector like these ones. So these three PCBs together make the entire project. Just one thing, I had to solder a separate OLED screen because the pins that I've used for my PCB are rotated 180 degrees. Anyway, I've already corrected that on the Gerber files. Now all the components are soldered, so it's time for the code. The first thing to do is to start heating the tip, and you write down the analog reads from the thermocouple and the real temperature with a thermometer. I take a note each 20 degrees or so, and I create this graph. Using these values, I can calculate the formula of passing from analog read to real temperature in degrees, and use it here in the code. This function reads the ADC and passes the values to temperature. Also in the code, using the temperature, I make a PID code, and that will control the PWM signal that goes to the power MOSFETs. Like that we can control the heating process and keep a steady temperature. And very important, we need to turn off the power MOSFET before each temperature reading, because the thermocouple is in series with the heating element of the tip, so we can measure it while powering the heater. That's why in the code I place the MOSFET to low, add a small delay, and then we read the temperature. The code looks ready, and you have it below if you want to download it. Now we can solder the screen PCB on top of the controller PCB like this. For the test I was using my power supply, but this is made to work with this 18650 battery. So to keep the battery, the PCBs and the USB connector together, I need to design a case. And this is the design. I've made more than 6 versions till I got something that is small, compact and looks good, and for sure I will make it better in the future. I 3D print the case using my resin printer. It has a hole for the USB connector, so you could add that with 2 wires for the battery negative and charging VCC. Now I take the controller board with the display and make sure that it has the positive spring for the battery. As you can see, the case has some pins for the PCB, so it will fit perfectly. With the PCB in place, you can test if you can add the battery. And if yes, we can solder the wires from the connector to the main PCB. To close the case, we use the other 3D printed part as a cover. And we can use some small screws and close the case. And that's it, but before we assemble it, upload the final code, which you could download from below. And there you have it, a fully portable soldering iron. It has sleep mode, so it will turn off automatically when not used, minimizing the battery use, because we don't have much. Also, it only uses a lot of power when heating up or when in use. For keeping a steady temperature, the power usage is very low. As you remember from the previous version, we used the PWM signals to control the power, and just keeping up the temperature, the PID output is minimal. Here we have a speed test, and it reaches 300 degrees in around 15 seconds, which is not bad, and we could make it faster by making the PID code more aggressive, but with that it might overshoot. It's also quite precise because I set it to different temperatures and it keeps the values at that set point with no problems, so the PID works. We can use the other 2 buttons to adjust the settings for temperature, the sleep mode time, the screen rotation, and so on. Oh, and changing the tip is very easy, just a few seconds. You can check all the information on my website electroops.com. So guys, I finally have my fully portable soldering iron working. I'm happy I was finally able to make it after all these years of work. It's small, simple to use, powerful enough for small electronics projects, and is fully portable. No wires, no soldering stations, no extra devices needed. Just the iron, which weighs very low. Check my PCB's files and the 3D files together with the code on my website, electronoobs.com, and consider supporting me on Patreon. That will help me a lot in these hard days for my YouTube channel. And if not, consider giving me a like or comment below. Thanks again, and see you later, guys. So guys, here I am in my workshop, another video that ended. I hope that you like it, and the most important part, I hope that you have learned something new. Anyway, I just wanted to give a thank you to all my patrons, to you guys, to the viewers who are supporting me, liking my content, sharing it, commenting below. Just check my website, check my shop, check my t-shirts. All this kind of stuff will support my channel, so thank you very much once again.